Hi everyone, the next section we're going to cover is 8.2 and it's on the Pythagorean Theorem and its converse. So we've been using the Pythagorean Theorem since really week 1 this year, and you've been using the Pythagorean Theorem for even a couple of years before we started it up. So you're pretty familiar with the Pythagorean Theorem, but in this section we're going to see how we can use the converse of the same theorem, and it's actually pretty useful. You can determine whether or not a particular triangle is a right triangle using the theorem, and you can also determine if it's an acute or an obtuse triangle. So that's what we are going to be looking at in this section. Okay, so the Pythagorean triple is really the only new vocabulary term here in this section. And what that means is that you have a right triangle, and that right triangle has all sides that are whole numbers. So you've got a right triangle with sides that are whole numbers, and whole numbers meaning integers greater than 0. So that's actually pretty special because most right triangles are going to have square roots as side lengths. The very first Pythagorean triple is a 3, 4, 5, and you're pretty familiar with that. Well, in fact, any multiple of 3, 4, 5, for instance, 6, 8, and 10, obviously my drawing's not drawn to scale here, any multiple of 3, 4, 5 will also be a Pythagorean triple. But those aren't the only Pythagorean triples, and we're going to take a look at that in a minute. Alright, so the Pythagorean theorem. The Pythagorean theorem states that if you have a right triangle, then the square of the hypotenuse, in this case C, is going to be the sum, equal to the sum of the squares of the two legs. So C squared equals A squared plus B squared. And when using this theorem, you just have to be careful that the longest side is always going to be that hypotenuse. So make sure that you know that C is the longest, okay? That hypotenuse is definitely going to be longer in length than either A or B. So let's take a look at how to use this. And you're pretty familiar with this already, but C squared equals A squared plus B squared. And in this case, the hypotenuse is always going to be across from that right angle, and so in this example, our hypotenuse is x. So we're going to just substitute the leg lengths in there. X squared is going to equal 16 plus 49. X squared is going to equal 65. And if we take the square root of both sides to solve for x, then x is going to equal the square root of 65. It's always a good idea to see if you can simplify this, but in this case you can. If you look at 65, 65 I believe is 5 times 13, and 5 and 13 are both prime numbers, so that should tell you right away that square root of 65 is as simple as it gets. Now let's take a look at an example on how to solve for one of the leg lengths. So here again, C squared equals A squared plus B squared. It's pretty easy to make this mistake, but always make sure you get your bearings using that right angle. Right across from that right angle is the hypotenuse. So in this case, when we substitute in, 12 is going in for C. C is always the hypotenuse, and we've got 8 squared, and x squared is going to be one of the legs. So we have 144 equals 64 plus x squared. If we subtract 64 from both sides, we get 80 equals x squared. I'm going to continue working over here, and I'm going to take the square root of both sides in order to solve for x, and x equals the square root of 80. Now we can rewrite that and simplify that a little bit. The first thing I think of is that 80 is 4 times 20. So I'll put that up here, 4 times 20, and you can see that 20 is 4 times 5. So here I'm going to just rewrite this, 4 times 4 times 5, and I've got two perfect squares here, two 4s. So the square root of the first 4 is 2, the square root of the second 4 is 2, so out here we end up with 2 times 2, or 4, and inside you just have square root of 5. Alright, here's a nice helpful chart. I already mentioned the Pythagorean triple 3, 4, 5, so you can see any multiple of 3, 4, 5 is going to give you that triple. The next Pythagorean triple is side legs of 5 and 12 with a hypotenuse of 13. So any combination or any multiple of 5, 12, and 13 is also going to be a triple. Another is 8, 15, 17, and any combination there is 7, 24, and 25. And any multiple there is going to give you a triple. All right, let's see what the Pythagorean theorem converse is all about. So the theorem itself says, if you have a right triangle, then the hypotenuse squared equals the sum of the squares of the legs. Well, the converse of that is when we take that if statement, the hypothesis, and the then statement, which is the conclusion, and we reverse the order of that. So what would that mean? That means if you have a side length, the longest side length squared, equaling the sum of the squares of the other two sides, then it must be a right triangle. So you can kind of go in reverse with this theorem. So using that, we could take, well, let's just take some numbers. We said 6, 8, and 10. If I said tell me whether or not a triangle with these lengths here forms a right triangle, you're going to go back to the theorem here and you're asking yourselves a question. C squared, does it equal A squared plus B squared? And what do you choose for C? Well, you're always going to choose the longest side here because the hypotenuse is the longest side. So, oops, I made a little mistake there. 10 squared, does that equal, question mark, 6 squared plus 8 squared? And if it does, then you have a right triangle. So we have 100. 30 equals 36 plus 64, and still a question, and yes, 100 does equal 100, and in that case, you would conclude that this triangle is a right triangle. And that's how you use the converse. Now, you can also tell other things about triangles. Even if C squared was not equal to the sum of the squares of the other two sides, you can still classify the triangle by either acute or obtuse. And here's how you do it. So here, if we try this C squared and see how it compares to the sum of A squared plus B squared, if C squared turns out to be smaller, less than that sum, then you have an acute triangle. And if C squared turns out to be larger than the sum of A squared plus B squared, then that triangle is obtuse. Now on the surface, it looks like this is going to be memorization, but if you kind of think about it in a logical manner, if C squared here, over here, if C squared is big, it's bigger than the sum of the other two square sides, then that angle across it must be big. So the longer this side is, the angle across it is going to be big, therefore obtuse. Here, where if C squared is smaller than the squares of the other two sides, then the angle opposite must be small. That means it's going to be acute. So instead of just rote memorization here, try to use a little bit of logic, and I think it will make sense. All right, so first, example 4, determine whether the set of numbers 7, 8, and 14 can actually make a triangle. If you recall, not all side lengths are going to make a triangle. And the rule is that any two sides, sorry, I'm going to go back here. The sum of any two sides has to be greater than the third side. And that's important, and you have to look at all combinations. So if we look here, 7 plus 8 is greater than 14. 15 is greater than 14. 14 plus 8, of course, is greater than 7. And 7 plus 14 is greater than 8. So this is definitely going to make a triangle. Let's see what type it is. We're going to use the converse of the Pythagorean theorem. So go to the largest side, in this case is 14. And we're going to put that in for C, and we're going to compare this to the sum of the squares of the other two sides, so 7 squared plus 8 squared. 114 squared is 196, I believe, And we're going to compare that to the sum of 49 plus 64. 49 plus 64 is 113, if I did my math right. So as it turns out, 196, or c squared, is greater than 113. Well, we can conclude two things. One, we do have a triangle. All right. Two, this is not a right triangle. Otherwise, we would have had equality. And finally, if c squared is greater than, that means the angle across from c must be big. So we're going to conclude, yes, that this triangle is obtuse. Let's try another example. We've got three sides, 14, 18, and 33. First, let's see, can this make a triangle? So we've got 14, 18, and 33. Clearly, the sum of 18 and 33 is greater than 14. But let's check this sum out here. 14 plus 18 is 32, which is not greater than 33. Therefore, this is not even a triangle. So we can't even close that up. The sides are too short. All right, and that concludes this video. I hope it helps. Take care.